Hello, everybody. Welcome back to Math 245. This week we have been talking about solving systems of linear equations, and so far, once we get to the end of the problem, we have something like x equals a number and y equals a number. So every single problem that we have solved so far gives us exactly one solution. We have exactly one x value at the end and exactly one y value at the end. But this won't always be the case, and that's what we are talking about today. So today is all about identifying different types of solutions to these systems of equations. So when I solve a system of equations, I have three possibilities for the number of solutions that I have at the end. The first type of system is called inconsistent. Whoops. It's called inconsistent. And when I solve an inconsistent system, it will look something like this at the end. Something that's not true. So maybe at the end of solving this system, I get something like 0 equals 3 or 2 equals 5. Something that's not true, right? I think we can all agree that 0 does not equal 3 and 2 does not equal 5. So that's what it will look like if we have an inconsistent system. If we go through the problem as we've been doing and we get to the end, it looks like this. We know that we have an inconsistent system. That means that we have no solutions. We do not have an x value and a y value that satisfy this system of equations. Our graph will look like parallel lines. They never cross. Remember, when we have a graph, our solution is where our graphs intersect. So if I have this inconsistent solution, this means that my graph does not cross the other graph. So we have parallel lines. Our next possibility is an independent system. And when I solve an independent system, I get something that we've been seeing before. So something like an ordered pair. So x equals 3, y equals 2. This is what we've been seeing so far. If I have an independent system, I simply get one solution, which is this xy pair that we find. And as we've seen, if I have one solution, this means that the graph crosses exactly one time. So this intersection right here is our solution. That's what it means to have an independent system. And our last possibility is called a dependent system. If I solve a dependent system and I get to the end, I get something that's true. So maybe it says 3 equals 3 or x equals x. Oops, x equals x. I want to make a note that we will not know if we have an inconsistent, independent, or dependent system until the end of the problem, when I either get something that's not true, something that's true, or something that is always true. Sorry, something, I think I just said something that's true twice. Something that's not true, a solution like x equals 3, y equals 2, or something that is true. A dependent system has infinitely many solutions. That means that our lines are the same line. They are always intersecting each other. So I have lines that are basically on top of each other. So these are the same lines. Remember, our point of intersection is the solution, but here, every point, the lines are intersecting. So these are our three possibilities. Inconsistent means that I have no solutions or parallel lines. Independent means that I have one solution and that my lines cross once. And a dependent system has infinitely many solutions. That means that my lines are exactly the same. So let's do some examples where we see how many solutions our equation has. So our first example says, how many solutions does the following system have? We have x plus 3y equals 3 and 2x plus 6y equals 5. I have several ways that I can solve this system, right? I'm going to multiply the top equation by -2 so that when I add these two equations together, my x's cancel out with each other. There are other ways to solve this system. For example, we could also solve the first line for x and then use substitution, but I'm going to be multiplying this top guy by -2. When I do that, I get -2x minus 6y equals -6. And then on the bottom, I just have 2x plus 6y equals 5. Well, when I add these two equations together, my x's cancel out and my y's cancel out. So I'm just left with -1. So this gives me 0 equals -1, which is obviously not true. This tells me that I have no solutions. There is no x or y value, x and y value pair that solve this system of equations. All right, our next example, we have another system here. How many solutions does the following system have? I'm going to now multiply the top equation by 3, -3. If I multiply this top equation by -3 in order to make the x's cancel out again, I get 15x, positive 15x, plus 18y is equal to -48. And then on the bottom, I will have -15x minus 18y is equal to 45. So I multiplied the top equation by -3 so that my x's on the top equation and the bottom equation would cancel out if I solved this using addition. But when I add these two together, check out what happens again. I get 0x plus 0y is equal to -3, or 0 equals -3. Obviously, this is not true, so I have no solutions. Okay, before we move on, I would like for you to pause this video and give the next example a try on your own, practicing the skills that we have been learning this week. So go ahead and pause this, give it a try, and then we'll do it together. All right, hopefully you've given this one a try. This one is perfectly set up for addition, since the coefficient in front of the x's are the same number but opposite signs. So this is perfect for addition. I'm going to add these two together. So I'll have -8x minus 3y is equal to -14. And then I have 8x minus 3y equals 2. Again, perfectly set up for adding. So when I add these two, I have -8x plus 8x equals 0x, exactly what I wanted to happen. And then the y's give me -3y minus 3y is equal to -6y equals -14 plus 2 is equal to -12. So I divide both sides by -6 to get y equals 2. But this is only 1/2 of my solution. To solve for x, I need to plug this y value into either one of my original equations, and then I can solve for x. So that's what I'm going to do. I'm going to plug this y value into the second equation. So I get 8x minus 3, 8x minus 3 times our y value, which is 2, equals 2. So I get 8x minus 6 equals 2. Adding 6 to both sides gives me 8x is equal to 8, which means that x is equal to 1. So in this case, I have exactly one solution, and I know that I have exactly one solution because I just end up with an x value and a y value that satisfies the systems of equation. So this gives me one solution. We call this a consistent system. Here our solution is 1, 2. All right, I think we have one more example here. We want to find the solution to this system of equations. Okay, I'm going to solve the first equation for x and then use substitution. But again, we know lots of strategies at this point to solve these systems of equations. So if I solve the first one for x, I have x plus 2y is equal to 3. To solve for x, I subtract 2y from both sides, and I get x equals 3 minus 2y. Now that I have x solved for in terms of y, I'm going to replace this x right here in our second equation with this right here. So the second equation says 2x, but I know that x is equal to 3 minus 2y plus 4y is equal to 6. If I multiply this 2 out to both of these terms, I get 6 minus 4y plus 4y is equal to 6. My minus 4y and my plus 4y cancel out with each other, and I get 6 equals 6, which is a true statement. So remember, if I go back up here, if I get something true, that means that it is a dependent system, and I have infinitely many solutions. So this tells me that I have infinitely many solutions. Infinitely many solutions. All right. So that was a short and sweet lesson all about different kinds of solutions. We can either have no solutions, one solutions, or infinitely many solutions. Hopefully you feel good about this. If not, make sure to leave a question or comment on the discussion board for this lesson. And we do have one more lesson today after this, so go ahead and check out lesson number 5 on the Canvas page. See you soon.